Inverse trig functions. The inverse is used to find the angle. Recall we had sine of theta equaling x. Theta is the angle, so theta is equal to sine inverse of x, or theta is equal to the arc sine of x. Same thing for cosine. Theta equals the inverse cosine of x, or theta equals arc cosine of x. And same thing for tangent. Theta of tangent inverse of x, or theta equals arc tangent of x. So we have some examples. We want to find the corresponding angles. Pull up our calculator. We want theta here in degrees, so this is decimal. We want to the nearest minute here, and then radians. So what we need to do is go to mode, and we want to have degrees first. So we want to do tangent inverse. Because here we have tangent of theta, we want to do tangent inverse. So do second tangent of 2.47. So it's 67.96 degrees. So it's 67 degrees. And we can figure that out by going to second apps. Option 4. So this is 57 minutes, and that's 32 seconds. So remember the clock over halfway is 30 seconds and above. So we're going to round this to 58 minutes. What I recommend is doing all of these and then change your calculator to radians, so you don't have to go back and forth so much if you understand it well enough. So we want to do radians. So tangent inverse of 2.47. So that's 1.186. And we're going to keep going and doing all of these. So the next answer is going to be 65.70. That's the same as 65 degrees and 42 minutes. And that's 1.147 radians. So please pause the video, try doing these on your own, and then play it to see if you got the answers correct. C would be 70.97. That's 70 degrees, 58 minutes, 1.239 radians. D, the centimeters cancel out, so just take 83 divided by 400 to get yourself a number. That's 11.72 degrees. So it's 11 degrees, 43 minutes, 0.2046 radians. E, 37.81 degrees, or 37 degrees, 48 minutes, 0.6598 radians. F 29.03 degrees, 29 degrees 2 minutes, and 0.5066 radians. Let's move on to finding an angle with the information that we just learned. So here's the angle we are looking for. This is the hypotenuse since it is opposite of the right angle. And this is the angle, so this is adjacent to the angle. This side would be opposite. So we have adjacent and hypotenuse. Which trig function has adjacent and hypotenuse in it? That would be cosine. So we're looking for cosine of theta is adjacent over hypotenuse, so 13/20. So when you take the inverse of cosine on both sides, you get theta equaling, if we pull up the calculator, we're going to go to second cosine, so that gives you what is in blue, cosine inverse. We'll put this one. There we go. 13/20. And let's make sure you're in degrees, and we're not. So that is usually a common error. I kind of noticed it wasn't degrees because less than 1 degree is a little suspicious. So that's why I checked. So our answer would be 49.46 degrees. Okay, let's move on. Here's our next triangle, and here's our angle. So we have opposite over hypotenuse. So that would be sine. Remember, we have SOHCAHTOA, and so sine is your opposite over hypotenuse. So try and set this up. You're going to have sine of theta. What's your opposite? 40. And then your hypotenuse is 42. If you take sine inverse of both sides, you're going to get rid of this sine and you'll be left with theta, which is what you're solving for. And then you want to do sine inverse of 40 divided by 42 on your calculator, giving you 72.25 degrees. Okay, so we did cosine, sine. What do you think the next one will probably be? Probably tangent. So if we look here, we have our angle down at the corner here. We have opposite and adjacent. So tangent is opposite over adjacent. So we're going to solve for theta. That means do the inverse of tangent on both sides of 27 divided by 38. So this angle that we just solved for is 35.39 degrees. Okay, let's just double check. That looks good. That is the end of this lesson.